All right, so we have a block of mass m initially at rest on the frictionless floor. The block is attached to a massless spring with a spring constant k initially at its equilibrium position. An arrow with a mass m and velocity v shot into the block. The arrow sticks in the block. What is the maximum compression of the spring? So this situation goes something like this. There's an arrow. There's a spring mass system. Okay, and when you shot this arrow is moving with a velocity v, and it has a mass of small m. This has a mass of capital M. This has a spring constant k. This arrow hits this block first of all, and it gets stuck. So they start moving together with some final velocity. We don't know what is that. And with that velocity, the block will be compressed. I mean, the spring will be compressed, my bad. So what they're asking is find this displacement. Do you get the question? If the question is clear, I think then we can move ahead. So there are two things that we will have to use. One is called as conservation of energy, which we need to apply. One is called as conservation of momentum. So both the conservation we'll have to apply. Okay, so yeah, let's do it. How do we begin with this one? So if you want to find x, we know one thing. We know that all the kinetic energy that they possessed here is converted into potential energy. All the kinetic energy that was here is converted into potential energy that is here. And to find the kinetic energy, we need to find the velocity of the whole system. What is the system? Arrow plus block. How do I find the velocity of the whole system? For that, I will use momentum conservation. First, let us apply conservation momentum. Apply conservation of momentum. So let's do it here. Wait, what? Apply conservation of momentum. Which says that total initial momentum equals total final momentum. So initial momentum is mass of the arrow, velocity of the arrow. Mass of the block, velocity of the block. What is final? They are sticking to each other. Like they are getting fixed into one another. That's like case of perfectly elastic collision. Perfectly inelastic collision. I should write it as perfectly inelastic collision. You should be able to identify these kind of things. So you will have m plus capital M. They stick to each other. So that becomes a one single mass. And they have a one final velocity, Vf. So what can we get Vf as? Vf can be written as small m times small m plus capital M times the velocity v that is given. Fine. Now, how do we proceed further? So we got the velocity vf. Now we just need to find say that the total initial energy is converted to total final energy there. So apply conservation of energy. When we apply conservation of energy, it says total energy initial is equal to total energy final. Initially, if you see, there is no potential energy, plus kinetic energy initial is equal to potential energy final plus kinetic energy final. At initial point, it was at rest. Initially it was at initially it was moving. Initially it was at mean position. So potential energy is 0. Final position, it is at extreme position. So kinetic energy is 0. So initially potential energy is 0 and kinetic energy is 0 at final point. Why? Because extreme position. And why this? Because mean position. So you have extreme position and mean position, both the things. So total kinetic energy initial is equal to kinetic potential energy final, which becomes half m. Now, hold on. When you're doing kinetic energy, you need to consider the kinetic energy of the whole system. What is your system? Your system is arrow and the block. Okay, your system is arrow and the block. And this times v final squared, and that is equal to potential energy, which would be half kx squared. These halves will go away. So this would be m plus capital M. V final squared. If I put v final squared, I will get m squared over m plus capital M squared times v squared is equal to k times x squared. So I can just put this squared out. I can write x squared is equal to m square v square over k times small m plus capital M. Take the square root, you will get x is equal to mv over square root of k times m plus capital M. So that is our option number D. Option D is the correct answer. Okay, see, this may look a very lengthy problem. This is not. The reason it is looking lengthy is because I have explained you each and everything. But once you get the hang of it, okay, half of thing will be done in your mind only. Okay,